Alright, in this video we are going to look at a very important concept when working with data in R, and that is subsetting. So I've tried to simplify this down to kind of two different types of things, and I've called them slicing and filtering. Okay, so let's tackle slicing first. Slicing is just when you take a full data set and you chop it up, and you might chop columns off, or you might select certain columns, or you might select certain rows. So you could chop all of the bottom 100 rows off, for example, or you could sample n number of rows. Let's give you an example. Let's carry on with the file that we've been working on in R. So I've still got this variable called data. Okay, so let's slice. Let's create a variable called slice. And what I'm going to do here is I'm going to take my data, which is, of course, a data frame. In fact, if you just type it, it will show it. I just did that, didn't I? There you go. It actually tries to preview it. Then I'm going to use a square bracket. Okay, now I'm going to put in a couple of numbers here. The first thing I'm going to do is this 1:1000, and then I'm going to put a comma, and I'm going to do 1:10. So let's explain what we're doing here. These first two numbers, just like in Excel, when you specify the rows, you'll put A1 colon A2, right? Or A1000. This is the column, so I'm going to do 1 to 1000. So I am going to simply select rows 1 to 1000 in my data frame, and the second here after the comma is my columns. So I'm only going to have 1 to 10 columns. Okay, so if I run that, I can see now there's another data frame here called slice with 1000 observables and 10 variables. If I click on it, you should see, okay, it looks very similar, but I've only got the 10 columns, and it only goes down to row 1000. Okay, so that's one way of slicing it. That's not very sensible in this case. I don't want to truncate my rows in this case. So actually I want all the rows. So if I wanted all of the rows, I could leave that bit blank and just have a comma. If I run that again, you can see now that that's gone back up to 2000. So I've got all of my rows in there, but only the first 10 columns. That is okay. It's still not terribly useful, because sometimes you're more like, well, sorry, not more likely, most times I should say, you are going to want to select specific columns. Okay, so in this case, I only really want to look at 3 columns in my example. I'm going to look at the order column. I want the adult body mass, and I want the basal metabolic rate. Okay, so I am going to do something a bit funky, which is this. I'm going to type C to begin with and open up a bracket. So what I'm doing here is I'm actually creating a list, or what's called in R a vector. Okay, if you go and use another language, they might call it a list. Python uses lists, for example. And I'm going to put in the verbatim name of the headers of my columns. Now, you have to be very, very careful here to make sure that you've used the right names, which have the right case and they're spelled correctly. So you can type them in, or if you want to be absolutely sure, you can do something cool like col names and then data to get a full list of the column names, and you can either copy them there or you can cut and paste. So I know the order, I shouldn't have too much of a trouble with order. Note the capital letter, that's important on the O. I'm also going to put in the, where is it, adult body mass. I'm going to cheat here and I'm going to cut and paste. Remember, oh, wrong place, I've pasted it in the wrong place, that's okay. Remember, they've got to be in quotation marks because they're strings. And the last one is going to be basal met rate milliliters O2 per hour. And there's a lot of different uppercases and lower cases there, so I'm definitely going to cut and paste that one. Okay, to run it, Control and Enter. I'm actually going to delete that line because I don't need it anymore. And there we go. I should have a new a new slice, and this time now you can see there's only 3 variables in there. Let's click on it, and you can see I've just got those 3 columns. Brilliant, fantastic. I've sliced. I've learned how to slice. Oh, that's weird. What are all these minus 999 values in here? I don't like the look of those, and they're in both columns of my data. I can see them here, lots on the right, and a few on the left as well. In this instance, whoever's collected this data has used minus 999 to represent a value that wasn't measured. Okay, so think of this as blank data. Okay, now it's not conventional to do it with minus 999. Don't know why they did that. Sometimes you'll just have a missing cell, or it'll say NA. Okay, or you might even have an empty string, which is a nightmare. But you can filter these out, and that was the key word. I just used it, filter. So the other way of subsetting your data is to filter it on some condition. And that is the difference between slicing and filtering. Is slicing, you're just chopping up. Filtering is you're using some logical statement. In this case, it's going to be if value is greater than or equal to 0, include it. And if I do it greater than or equal to 0, then it's going to ignore any negative number. Okay, and all of the values should be positive in this case. It doesn't make any sense to have a negative mass, for example. Okay, so how are we going to filter this? Well, I'm going to, surprisingly, give yourself a bit of space, use a new variable name called filter. And I'm going to do the following. Now, I'm not going to use my data variable anymore. Okay, I'm only going to refer to my slice. That's my new data frame with just those 3 columns in it. Okay, and I'm going to do this. I'm going to put the square brackets again. Now, this is the important bit. I'm going to call the data again. Okay, but I'm going to hit it with a $, and I'm going to select the adult body mass column. And this is the interesting bit. I'm going to do greater than or equal to 0. Okay, that in coding is what we call a conditional statement. And it's this. What is actually going to happen here? It's going to use this statement, look at all of the rows, all of the values, I should say, in my adult body mass column, and it's going to go, is it greater than 0? Yes or no. Is it greater than 0? Yes or no. And it's going to go down the whole thing. And what it will generate is a massive list of yes or no's. Well, I should say true or falses. Okay. We call that a Boolean vector. Okay. Doesn't matter to me what we call it, actually. It's just a list of yes, no's. Okay. And then what we do is we are actually, within these brackets here, we're actually feeding the result of that to my original data frame and saying, well, let's select all of the rows that are true or yes. So it's only this slice with the square brackets and my conditional statement is going to give me all of the rows, or only the rows, where the adult body mass values are greater than 0. And it's going to store all that in a new variable called filter. In fact, I can do that. Here we go. Okay, I've done something wrong. Undefined column selected, adult body mass grams. So that means, or it looks like, I have gotten the name of my slice wrong. Let's make sure. Adult body mass grams. What have I done wrong here? Okay, make sure we've cut and pasted this correctly. Ah, I've fallen into my own trap. Well, okay, that was worthwhile. So I'm going to get this error if I just do that. And the reason for that is, remember when we were slicing earlier? I did, where's my slice? My columns, comma, rows. Okay, so what I've forgotten to do, so I'm just looking at rows here, but I've forgotten to include my columns. So I need to put a comma there, and then select all of my columns. Now I want to keep all of the columns, so I'm not going to put any numbers in there. So it was that comma at the end of that conditional statement that was tripping me up. There we go. I've now got a filter. And you can see I haven't got any minus 999 values in my adult body mass column, but I have got them in my basal met rate column. So I want to also filter out the minus 999 values in my basal met rate. Now to do that, I can use an AND condition. So that's a shift and then I'm going to do the same thing, slice, but this time I'm going to select the basal met rate greater than or equal to 0. Keep the comma at the end, that's important. Control and enter, filter. So I've only got 251 now observers. So I've actually cut the whole thing down from 2000 to around 251 values. Let's take a look. There we go. So I haven't got any minus 999 values in there now. Okay, perfect. So I've learned how to slice, I've learned how to filter. Now this would be a tragic waste, wouldn't it, if we didn't do anything here. So we're not going to really talk about visualization until the next chapter. However, I am going to go to my book here. I'm going to take this piece of code I've got down here, and in the so what section, I'm going to copy that, and I am going to paste it here. Okay, and I'm totally cool with that. Okay, and I can run this plot function, and we'll talk about that in a sec, by clicking anywhere in the function. I'm going to click on the first line and then click run. I'm missing something. Error in slice adult body mass. But I made a mistake there. I noticed a mistake in the book. I have to go and change that. It said subset instead of slice. Don't know why I said that, but it should be slice here. I'll change that in the book. So when you cut and paste it, it should be okay. Right. Yeah, we all make mistakes, right? Now I'm going to click run. And there we go. I've got a graph. It looks a bit squished up, so I'm going to pull this over like this. Pull up like that. There we go. Right, so that's quite interesting, isn't it? So let's discuss what this graph is actually showing. It's showing that if I plot the log of the body mass versus the log of the basal metabolic rate, I get a straight line, approximately. You can see there's definitely a linear relationship through this data, which is really, really interesting. And that is interesting because this is every mammal that we've measured. So from the smallest mouse up to the biggest whale. And there is a linear relationship between the log of the adult body mass and the log of the basal metabolic rate. Okay, they call that an allometric relationship. In biology, there's a whole field dedicated, and it's a really interesting quirk of nature. You see this all the time. So that's really interesting. So very, very quickly, by slicing and filtering our data and plotting a simple plot, we can start to really gain some key insights about our data. Okay, right, that's it for this section, and I will be careful to edit out the bits that I've gone wrong on. I'll leave in the instructive errors for you. Okay.